Meteors have always been a cause of fear for humans. They have been responsible for many extinction events and other destruction on Earth before. In April 2018, the B612 Foundation reported it's 100% certain we'll be hit by a devastating asteroid, but we're not 100% certain when. Throughout recorded history, hundreds of Earth impacts and exploding bolides have been reported, with some occurrences causing deaths, injuries, property damage, or other significant localized consequences. One of the best-known recorded events in modern times was the Tunguska Event, which occurred in Siberia, Russia in 1908. It is the largest impact on Earth recorded in recent history, though many other impacts have occurred in the prehistoric times. On June 30th, 1908, in a woodland area surrounding the Tunguska River, close to modern-day Krasnoyarsk, known as Tunguska, one of the most desolate areas of the most desolate region of the Russian Empire, an enormous explosion occurred. In a few minutes, the sky opened in two, torn asunder by fire and a sound of thunder. It was a very mysterious event that took about 105 years of research to complete. We usually attribute the explosion to the airburst of a meteoroid. At about 170 kilometers or 110 miles from the impact, just before the explosion, an object was spotted in the clear daytime sky as a brilliant sun-like fireball traveling at enormous speed, leaving a trail of thunderous noises. 60 kilometers or 40 miles from ground zero, at the time of the explosion, people were thrown to the ground by the shock waves, or even knocked unconscious. Trees were set ablaze and had fallen to the ground, their tops pointing radially away from ground zero, like giant arrows. Windows shattered in a hail of shards, while furniture, crockery, and other objects fell to the ground. The blast nearly flattened 80 million trees over an area of 830 square miles. What happened that day that would become one of the most mysterious and important events in history? Over the course of years, there had been many explanations for this event. Some were wild, such as the encounter of Earth with a stricken alien spacecraft, or a mini black hole, or a particle of antimatter. But the actual truth was rather more subtle. Today, scientists attribute the cause of the explosion to be an airburst of an icy meteorite about 100 meters in size. Days later, strange phenomena were observed in the sky of Russia and Europe, like glowing clouds, colorful sunsets, and a weak luminescence in the night. Unfortunately, the inaccessibility of the region and Russia's unstable political situation at the time prevented any further scientific investigation. The Tunguska region of Siberia may be a remote place with a dramatic climate. It has an extended hostile winter and a really brief summer. The region is sparsely inhabited. Then when the explosion happened, nobody volunteered to go to the location to find out what happened there. It would take 19 years before mineralogist Leonard Kulik organized an expedition to investigate what may have happened. Later in 1921, Kulik, who was a former soldier and now a professor of mineralogy, was charged with locating and examining meteorites that caused the explosion. He gathered all the information and read the old newspapers which had articles on the explosion. In the initial stages, he only figured out the location of the impact area rather than visiting the area. He read about the story of a family who had been knocked down by the force of the blast. The wife reported the forest was blazing around them with many fallen trees. Some children described a terrible storm, so great it was difficult to stand. On his second expedition in 1927, Kulik reached the town of Vanavara, located on the Tunguska River. The journey was full of hardships, as the maps and compasses were chaotic and the terrain inhospitable. He realized the locals feared going to the place of impact because they thought Ogdi, the local god of thunder, had cursed the area and burnt the trees. Kulik continued with his search team later in March and reached the Makurta River, where he first saw the first evidence of the Tunguska blast. The charred trees burnt to the ground. He suddenly realized it was an unusual event, not something that a flash of thunder could cause, but the locals ran away because of fear, and his team grew weary of infections and the hard terrain, so he returned later on May 20th. The direction of the trees were pointing towards the area of the impact, which he located finally in the southern swamp. Being a meteorologist, he intuitively thought the impact resulted from a meteorite impact, but it surprised him when he did not find any crater. Not only this, the trees near the epicenter were all standing in shard. Kulik wrote, "The solid ground heaved outward from the spot in giant waves, like waves in water." Later, he decides to leave because of a shortage of food. He returned later in 1929 and 1938, but both were inconclusive because of a single problem. How could there be no crater? Another scientist, E.L. Krenov, returned in 1940. His theory was that the meteorite had exploded mid-air, hence the absence of a crater. Was this possible? The Second World War put an end to his research. The fact that the event was investigated so late, the scarcity of information outside scientific circles, the secretive nature of Soviet regimes, all these factors have contributed to the proliferation of theories as to the exact nature of what really happened in Tunguska. Though there have been many outrageous theories, like the crashing of a black hole to the alien intervention causing the blast, but they all seem to be irrelevant. Studies have yielded original estimates on the meteoroid size, on the order of 50 to 190 meters, 160 to 620 feet. Continuing on whether the body entered with a high speed, it's estimated that the blast wave from the airburst would have measured 5.0 on the Richter scale, and estimates of its energy have ranged from 3 to 30 megatons of TNT. Expeditions from around the world within the 1950s and 1960s found microscopic silicate and magnetic spheres in siftings of the soil. The locals were so terrified by the blast that they didn't talk even about the event. Regional newspapers also reported the event shortly after it occurred. A herder reported the ground shook and an incredibly prolonged roaring was heard. It shrouded everything around in smoke and fog from burning falling trees. Eventually, the noise died away and the wind stopped, but the forest went on burning. Many reindeer rushed away and were lost. Another witness in nearby towns shared a similar experience. A fireball flashing across the sky, a ball of fire coming down obliquely. A few minutes later, we heard separate, deafening crash like peals of thunder, followed by 8 loud bangs like gunshots, another man reported. A ball of fire appeared in the sky. As it approached the ground, it took on a flattened shape. After the object crossed the sky and it approached the horizon, they consistently described it as a pillar of fire. The fireball appeared 2 or 3 times larger than the sun, but not as bright. The trail was like a fiery white stripe, its color sometimes changing to red and bluish white. The cause of the explosion at last points to the one obvious explanation. The obvious explanation was that a meteorite made of rocky material had exploded before hitting the Earth's surface, like Krenov had theorized. This explained the lack of a crater, but what about the absence of fragments? In 2013, a research team led by Viktor Kvasnitsia from the National Academy of Sciences of Ukraine analyzed microscopic samples of rock collected from the site and found them of the meteoric origin, as we have also discussed it before in the video. Nothing paranormal like an alien bombing, crashing of a black hole, or Nikola Tesla causing the blast, though the theory stating the cause of the blast to be Nikola Tesla is far more ridiculous. Today, the conclusion is that a large meteor collided with the Earth's atmosphere and entered our atmosphere at about 16 kilometers per second. Our atmosphere caused it to break, which resulted in a shower of many smaller tiny rocks. It is considered that the meteor might have been very fragile and obliterated its remnants at about 10 to 12 kilometers above the Earth. The atmosphere vaporized the object into tiny pieces, and the immense kinetic energy converted them into heat. This sudden heat caused the powerful blast, an extensive shock wave, and forest fires. 15 kilometers per second is a quick speed. Just imagine it like this. It could have flown the entire width of the US coast to coast in less than 5 minutes. Humanity was very lucky that the meteorite hit a desolate area that day. If it would have fallen in an urban area, The blow on the Russian Empire would have been devastating and would have left an enduring scar on the country. Past collisions with extraterrestrial bodies have had major effects on the evolution of the world. Some 4.4 billion years ago, for instance, a Mars-sized planetoid seemed to have struck our young planet, throwing out enough debris to make our moon. And an outsized impact may have caused the extinction of the dinosaurs 65 million years ago. Even today, cosmic impacts are evident. So Tunguska makes us ask questions about our preparations. When can we expect the next Tunguska? How would we tackle it? Well, recently, one already happened on February 15th, 2013, near Chelyabinsk, Russia. Seems Russia is a bit unlucky. This event created opportunities for scientists and other researchers to understand the event and prepare for such events. Though this event was less violent than Tunguska, it still caused damage to windows and several injuries. By combining clues from the magnitude of that event with the most recent asteroid population estimates, NASA researchers have concluded that the average interval between such impacts to be on the order of millennia rather than centuries. Still, we have to remain aware of these catastrophic events. Asteroids will hit the Earth sooner or later, but we have to be ready for them. NASA's researcher Lauren Wheeler said, because there are so few observed cases, a lot of uncertainty remains about how large asteroids break up in the atmosphere and how much damage they could cause on the ground. However, recent advancements in computational models, along with analysis of the Chelyabinsk and other meteor events, are helping to improve our understanding of these factors, so that we can better test potential asteroid threats in the future. And yes, we don't have to take the inspiration from Hollywood to train a bunch of drillers and train them as astronauts to deal with asteroids. Tunguska is considered an astronomical cold case because of lack of initial research done on it. That's all for this video. What do you think about any asteroid hitting us in the near future? What do you think about the news that an asteroid passed very close to us? Tell us what you think about the video, and feel free to ask your question in the comments section. And don't forget to like the video and subscribe to the channel, and press the bell icon to remain notified of our upcoming interesting videos.